Do the research. Ask questions. Be curious.
Those who can imagine anything can create the impossible.
Hey everyone. I'm going to lower these. My name is Allyson Klein. I am the principal of the TechArena. We are a technical publication that covers everything from data center to edge. And before I founded TechArena, I spent a quarter of a century in the silicon industry, which is our topic today, chips for the future, fueling business transformation with computing power. We have assembled an incredible lineup of technologists here with us today. And anything from industry leaders to disruptive innovators, and a company that's delivering foundational technology that helps silicon providers make it all happen. We have a packed agenda, and we are going to start in a moment with Sachin Katti, Senior Vice President and General Manager of Intel's Network and Edge Group. I will then be back for an executive chat with Salil Raje, Senior Vice President and General Manager of the Embedded and Adaptive Computing Group at AMD. And then we will have a panel, which will feature industry leaders from Ampere, Ansys, and Rebellions. But to kick it all off, I'd like to ask Sachin to take the stage. Thank you so much. Thank you.
Thank you, Allyson. It's great to be here. Thank you for the invite. When I was asked to come here, I was asked to talk about what kind of transformation businesses are going to experience over the next few years, and what kind of chips and architectures are going to come about to drive this transformation. And I was thinking to myself, actually, the industry has been going through a transformation pretty much for the last 10 years. We've been all in the middle of it. This notion of bringing the cloud all the way into the network, into the edge, making the networks virtualized, cloud native. It's been a long journey, but it's been a worthwhile journey, and we are well along into it. We've finished virtualizing the core. We are well on the path of virtualizing and making the RAN cloud native. But obviously, we can't go to a single meeting in this show without talking about the next big transformation that's upon us, which is, of course, AI. Right? And I was chuckling to myself. Today I had a meeting with a telco CTO, a customer CTO, and he was saying, I'm so confused. There's AI inside RAN, there's AI outside RAN, there's AI above RAN, AI below RAN, there's AI everywhere. How should I think about it? What should I do with this transformation? So joking aside, AI is a fundamental change. It is something that, unlike maybe past trends, is going to impact every aspect of the network architecture. So how should we actually start thinking about how do we bring it into this network, into this infrastructure? And the hard-earned lesson from actually driving the cloud-native transformation in the network over the last 10 years is that it is different. It's unique. It's different from the cloud and the data center. First of all, when you think about the network and the edge, you have to support a broad variety of workloads. It's not just AI. It's not just inference. You have to support a communications workload. You have to support a networking workload. You have to make sure that you can fit it within the form factors that you can afford to, within the power constraints you can, like a cell tower basement. It's not going to have a lot of cooling. It's not going to have a lot of power. So how do you build it in a ruggedized form factor, fit it there, and support all the different workloads that you're going to need, in addition to AI that's coming at us? Next, you need to make sure that connectivity is integrated, because AI is very bandwidth hungry. AI needs that compute density, that bandwidth density. How do you make sure that the workload is very close to the connectivity and the data is right next to the compute? So you can't be shuffling a lot of data around over very long distances. So how do you make sure that you deliver that integrated connectivity in the form factor that you need in a secure fashion at the edge and support a wide variety of workloads? This has been the hard-earned lesson over the last 10 years on the cloud-native journey. And one of the lessons that the operators have learned is you can't really go with purpose-built platforms. You need platforms that are general purpose. You need platforms that can actually scale across these different dimensions and have the flexibility to give you that programmability, to give you the ability to change and upgrade networks into the future as new use cases come along, because you cannot predict what's going to come next. So that's been our approach, right? So how do we bring all of this in a way that makes sense for the network, makes sense for the edge? An example of this is what we launched last week, which is the Xeon 6 SoC. And what I really want to do is peel apart the onion and talk through what is the approach here. So really, it's not just compute. Of course, you need that. This is very powerful. This has the latest performance cores, up to 72 cores, and it has all of the instructions that you need to build in AI acceleration at the edge. So in fact, many of these are capable of running up to 70 billion parameter models on themselves without needing an external GPU. So you get the ability to run a networking workload. This is something that can run a full base station software. But in addition, it can run an AI workload alongside. It can also run a media workload alongside. So as you think about the edge with the CDN, with vRAN, with AI, all of that in one form factor, in one server, all the way at the edge, with almost a 2.5x improvement in capacity and performance per watt improvement. So this has been very exciting for a lot of customers, because for them, it solves that practical problem that they cannot actually go deploy another piece of infrastructure. They really need that single form factor, single platform, which can handle all of these different workloads. So that's been a big step function, and I think that kind of embodies the thesis we are taking, which is we think AI will get added alongside the existing platform, on top of the existing platform. And we need to give customers and this whole industry an architecture that allows them to scale out gracefully over time, rather than have to make an upfront decision today on a new architecture, which is going to add cost and a lot of complexity to the infrastructure. So really, how do we partner with you? How do we partner with the whole industry in building platforms that give you that graceful scale-out capabilities over time, give you something that allows you to dip your toes into the water, run AI workloads today on existing infrastructure that you have to deploy for your networking workloads anyway, but then add AI capacity as you go along, as you discover the use cases, as the killer app shows up, that's actually going to drive this workload at the edge. And that's really something that with this kind of SoC approach, you can already begin to see the benefits of a lot of this. For example, the single thing is capable of handling 38 cameras, right? And this will just keep going better and better. It's 38 cameras, fully processed, doing all of the media transcoding, doing all of the AI and computer vision capabilities. You can run an LLM, as I said, up to 70 billion parameter models, depending on the memory you have. But very easy to run the most popularly used small and medium-sized LLMs on this. But more importantly, it's all the stuff that we don't hear about. It comes in a ruggedized form factor. It comes in a sled that is very easy to put in any of these harsh environments. You don't have a lot of space, at a cell tower. You don't have a lot of power. You have to worry about thermals. You don't have a lot of space in edge environments, right? So you have to worry about making sure that this can fit in a closet and does not have the same power and compute density requirements that we need with GPUs. So all of that's super important. And that's what we've been working on with our entire ecosystem, specifically OEMs and ODMs, to make sure that it's actually available in these SLED, very modular, very compact form factors that gives you the flexibility to deploy this in a variety of locations and get going with your network transformation. And as I said earlier, this drives that ability to drive that workload consolidation across the enterprise on a single platform, from networking to base stations and comms, to AI, to media transcoding. So whether you're a CDN, whether you're a telco operator, whether you're an enterprise who has physical premises that they need to manage and bring computer vision and AI into, in a single platform, you can actually run all of those solutions. One of the most interesting demos I saw using this product was a single solution running a private 5G stack, running a computer vision stack for 12 cameras in an airport, and then running an LLM alongside, a 7 billion parameter LLM alongside on a single platform, giving the operator of that airport the ability to interface with the system with a natural language and be able to analyze all the video that they're seeing and be able to communicate with all the cameras that are out there over a private 5G link. So that's the magic of having a consolidated platform that brings you that flexibility to bring this kind of transformation into your business. Now, I've been talking a lot about our technology, Intel's products, but it takes a village. We won't be able to accomplish this transformation without taking an open ecosystem approach, which we have been pioneering in this industry for the last 10 years. So working closely with our entire ecosystem is how we manage to drive the virtualization of the network, how we are still driving the virtualization of the RAN. Well past in that journey, almost 100% of the core is virtualized today, and a significant fraction of the RAN will get virtualized and cloud native over the next few years. The reason I bring that up is it's going to take that kind of an open ecosystem approach to drive that transformation for AI. It's not going to be driven by a vertically integrated approach that has a very opinionated way of doing this. We have to find the partnerships amongst us to understand the complexity of this infrastructure, to understand the varying requirements. And that open approach is how we will go after this with all of you. And a good example of this is you would never have heard about this maybe even 10 years ago, but Intel and AMD, and Salil will come up and talk about it, but we set up an x86 advisory group, coming together to make sure that we harmonize the x86 instruction set, we standardize it, and we reduce complexity for our customers together and make this kind of transformation easier and faster for all of you. Thank you again for the opportunity. Thank you for taking the time, and really excited to be here, really excited about what the next few years hold for all of us in this industry. Thank you.
We're back. And we're back. Salil, it's so nice to see you in Barcelona.
Good to see you.
So Salil Raje is here. You lead adaptive and embedded computing at AMD, which gives you a front row seat for what's going on in the edge. What are you most excited about in the space right now?
Thank you, Allyson. So super excited to be here. Now, before I answer that question, can I ask the audience, like, how many of you, maybe in the last week, have used ChatGPT already? OK, so pretty much almost all of you. Like, so I personally use ChatGPT almost every day now. But I have to say that even beyond the ChatGPT moment that we had last year, there's a huge transformation that's going to happen to us with AI at the edge. As AI moves towards the edge, AI will become very pervasive. It will take satellites talking to our devices. We'll have networks on the moon, maybe. We could even have networks that go all into the far reaches of the Earth. And that's what is actually exciting me. I run the embedded business at AMD. And our devices, the embedded processors, FPGAs, adaptive SoCs, are the ones that are driving this AI at the edge innovation. We are bringing AI closer to all of you, all of us. And as we get closer to us, we will make decisions. We'll have better use cases. It'll improve quality of life. And I do believe that there's a ChatGPT moment coming to the edge.
Now, we are talking about AI, and 2024 was filled with conversations about the cloud and the advancement in the cloud. 2025 is shaping up to be a little bit different. Tell me what's happening at the edge and what you're seeing.
Yeah, so absolutely 2025 seems to be shaping up differently, and it is, I think a lot of it has to do with it moving from the cloud, AI moving from the cloud, to having discussions now at the edge and the endpoint. And edge is becoming super important. And I think it's probably at some point will take over the cloud discussions. Already at MWC, I can see there's more conversations about AI, which I didn't really see last year. And edge AI is taking over. It's probably becoming a lot more important than even the cloud discussions.
Now, this requires unique infrastructure innovation at the edge. How is that shaping up?
So at the edge, there is a lot of innovations happening that are specific to the edge. For one, there are a lot of innovations in the models. People are working on innovating on the models, where they are pruning the models, quantizing the models, making it smaller, and making it such that they can fit within the power constraints, and they can fit within the form factor constraints at the edge. So that's definitely something unique to edge. There are also hardware innovations happening. There's a whole industry of NPUs, neural processing units, being created. There's a race going on with respect to TOPS per watt and TOPS per dollar for these hardwares that can run these larger and larger models, but at the edge, with power constraints and with performance, and form factor constraints. At the same time, there's a lot of innovations in sensors. There are all these 3D sensors, event-based sensors that act like biological systems and give real, sort of human-like experiences. So there's sensor innovations are happening. There's also this whole science of federated learning, where learning happens at the edge, in the devices, and only model weights get sent over to the cloud, and then the cloud actually coalesces these models, these weights, and sends it back to the edge, and so you can get better accuracy and better training at the edge and better inferencing at the edge.
Now, Salil, I know that in your job you talk to a lot of end customers across a lot of industries, and this is really where the value of these edge deployments start taking shape. I wanted to walk through a few of those with you. Why don't we start, let's start with automotive.
Yeah, so absolutely, businesses are innovating quite dramatically at the edge. They are thinking of it very differently now. Their data has to be processed differently. You have to respond to sort of stimulus very quickly, so latency becomes extremely important. In automotive specifically, you know ADAS and AD is a big thing, and people are moving towards full self-driving systems. But even beyond that, we see that people are creating AI companions in the cockpit, so so that they can give richer experiences to the driver. Now, we are working with Subaru in their safety systems. Subaru has a goal to have 0 fatalities by 2030, which is a phenomenal goal, and we are partnering with them to make sure that we can achieve that goal by 2030.
How about industrial?
Yes, a lot of innovations in industrial as well, and a lot of innovations in manufacturing, supply chain. There are mobile robots in the factory floor carrying products around. A lot of supply chain innovations in industrial where you can become more resilient to changing demands. In industrial, we are working with JR Kyushu. That's the biggest bullet train operator in Japan. And we are working with them to create a vision-based system to look at the tracks and inspect tracks and things like that. We are working with Radmantis, which is another interesting company that does sustainable fish farming.
Oh, wow. I wasn't expecting that.
Yes, exactly. And then, on the other end of the spectrum, we're working with SICK, which is another company that is looking at vision-based inspection systems on the manufacturing lines to detect anomalies on the manufacturing lines. So lots of different applications, very wide variety of use cases.
I think the other area that my mind goes is healthcare.
Yeah, absolutely. Healthcare, a lot of innovations in healthcare, a lot of innovations on sort of medical imaging. We are working with Hiroshima University to do cancer research. They are doing early detection of cancer. We are also working with Clarius. There's yet another company that does very interesting portable ultrasound that can do quick detection of and diagnosis. So again, many use cases in healthcare as well. The one that I'm most excited about in healthcare has to do with this convergence of AI and robotics. And that's creating these AI-based exoskeletons.
Wow.
Yeah, so they actually can work with people that have lost their limb functions and give them more functionality so that they can behave like able-bodied people. So that's improving people's quality of life quite significantly. So that's a very interesting use case as well in
That puts some perspective of why we do what we do.
Yeah, exactly.
We'd get kicked off the stage if I don't ask you about comms at MWC.
Oh, that's right. We didn't talk about comms, and we are at MWC. I would say that it's sort of. I had to say that comms industry is actually lagging behind in deploying AI. There's a lot of industry leaders here, and we have done a lot of discussions on AI, but we still have not gotten to a place where we are actually deploying AI. Now it's changing. And just yesterday, AMD announced with Reliance Jio, Nokia, and Cisco a new AI-powered telco platform, and where we will actually deploy AI across all the layers of the network. So that's happening. Also, it's heartening to see all the discussions about AI in MWC. But we are the industry leaders, and we are the technologists here. And I would say that it's upon us now to start deploying AI in the networks and make sure that we build upon these use cases.
Well, very cool announcement. Congratulations. One thing that, as you walk through all of those use cases, one question that I have is, where are we going to get to that ChatGPT moment?
Yes. So any of these use cases that I talked about in healthcare and industrial, in comms even, right, can become the ChatGPT moment for us. Every one of them has the potential. But the one I would bet on has to be the humanoid robots.
Okay.
These humanoid robots, will have many senses. They will have to act more naturally and have to train and adapt to the environment and do different tasks. I can just imagine each one of us having a couple of robots at home, and can you imagine the volume that will be dictated by that kind of use case, and that could become the ChatGPT moment for all of us.
That's very cool. I'm ready. Obviously, this needs silicon innovation
Yes.
to deliver upon this vision. What kind of performance is required, and what are you seeing in terms of the advancement of the workloads?
Yeah, so the silicon requirements and the hardware requirements for edge are very different from the ones that you see in cloud. And typically in cloud, you have inference and training, and a lot of it has to do with CPUs and GPUs, and they suffice in the cloud. At the edge, it's not just about inference. There are whole applications, as use cases that are deployed at the edge. Typically, these use cases have 3 steps. I mean, there's a pre-processing steps. You have to deal with all these sensors, and you have to do some kind of sensor fusion. There's an inference stage, and then there's a post-processing stage. And each one of these stages is quite different. And what you need is sort of a heterogeneous computing approach, where you have processing elements and compute elements that are assigned to each of the steps. And you need to combine all of these processing elements onto a single platform. So you also, on top of that, on top of heterogeneous computing, you need adaptability. These models are changing, the sensors are changing. So you need to be able to deploy these new models as innovation happens. And finally, I would say, you need scalability as well. At edge, there are different sort of variety of performance requirements. There are low-end requirements, and there are high-end requirements. There are market segments that you need to address at the low end. There are market segments at the high end. So your compute infrastructure and compute platform needs to be able to scale from the very low end to the high end. And you need to use the same software stack, so you don't have to redo some of the work that you did for the low end, going to the high end, right? So I would say heterogeneous computing, adaptability, scalability, those are the key elements of what's required at the edge.
Now, you and the team at AMD have put together an impressive portfolio. Can you walk me through it?
Yes, we are quite unique and very proud of our portfolio. We have, of course, the x86 CPUs. These are used in data centers, and can be used in inference. We have the Instinct GPUs. These are used for training and inference in the cloud environment. We also have FPGAs. We have adaptive SoCs. We have neural processing units. These are engines, AI engines, accelerators that are very performance, sort of power efficient. And these are used in AI PCs, so we are deployed in AI PCs for over, in millions of PCs, so people can just code and develop against those. But the one that I'm most proud of, and it actually talks to our portfolio, the IP portfolio that we have, is the AI Versal AI Gen 2 product. This combines all of our IP. So there are ARM processors, there are NPUs, there's FPGAs, and we can do sensor fusion with FPGAs. We can do inference with these NPUs. We can do post-processing with the CPUs. Right? So it combines all of the heterogeneous elements into a single platform, and we can do end-to-end application from pre-processing, inference to post-processing onto a single device. So that's pretty cool, pretty exciting. And Subaru is actually using that in their safety systems.
Wow, that's very cool. Very powerful foundation, but we all know in the silicon industry, it takes working from across the value chain. How are you approaching that?
Yeah, so AMD is very focused on ensuring that we work with an open source ecosystem. In fact, that's our differentiator. We do work with a whole host of ecosystem partners. These are partners in the model creation phase. I mean, we worked with Hugging Face that has several millions of open source models. We work with frameworks, PyTorch, and we can compile from PyTorch down to our platforms. We do believe in making sure that we bring in all the ecosystem partners. We do believe in our open source tools. We have no proprietary languages, no proprietary tools. We bring in all the ecosystem partners, and we believe that that's the way to succeed in AI.
Very cool. I've got one more question for you. We've assembled an incredible audience of leaders, both from a standpoint of those building technology and those deploying it. What is your message for everyone in the audience today about what you'd like to see in 2025?
Well, thank you, Allyson, and thank you, GSMA, for inviting me. Thank you for this question also. I would say that, look, ChatGPT was an enormous moment for us last year, but there's a bigger transformation coming at the edge. As AI moves to the edge, we will make split-second decisions that will save lives, that will transform our lives, and improve our quality of life. Now, the communications industry it has been at the forefront of technology. It's been at the forefront of connecting all of us. However, the communications industry is also a standards-based industry, standards such as 3GPP. And we also work in a stepwise fashion, evolving our networks, evolving our infrastructure. But AI moves at a much faster pace. So the industry, the communications industry, and the rate at which AI moves are inconsistent. We need to move much faster. Okay? All of the technologists here and the industry leaders here, we have the technology, we have the wherewithal, we have the talent. We should be able to move much faster. We cannot wait for 6G. We cannot wait for 6G. We absolutely have to get ready to deploy AI at the edge now.
That's great. Well, thank you so much. That's a strong way to end. Thanks so much, Salil. It was a great pleasure.
Yeah.
Thank you. You're not done with me yet. I'd like to invite the panelists up on stage with me. The far one.
I think it's here. Sunghyun, no one, which one I sit next to.
All right. All right, so we just heard a couple interesting conversations about edge computing, and we're going to open up the aperture a little bit from data center to edge. And we're just going to start with introductions. We'll start with Jayraj Nair. He's the CTO of High Tech and APAC at Ansys. We also have Jeff Wittich, Chief Product Officer from Ampere, and we have Sunghyun Park, CEO of Rebellions. And I'm just going to start with a quick introduction for each panelist to introduce themselves and their companies. Why don't we start with you, Jayraj?
Excellent. Good afternoon. Thank you for being here at this time of the afternoon. We have a lot of interesting topics to talk about. I'm Jayraj. I'm based in Seattle currently, but on the way to Japan. I'm the field CTO for High Tech as well as APAC. And Ansys, most of you must have heard of Ansys. It's the #1 simulation engineering company in the world. Looking forward to sharing some insights today.
Jeff?
All right, Jeff Wittich. I'm the Chief Product Officer at Ampere. Ampere has been building processors for data centers, for cloud, for the last 7 years. And our aim is to build high-performance processors that are also extraordinarily efficient. And as workloads have shifted, and with the rise of AI, those processors that we've built for data centers are also making their way into telco and into the network edge as well.
And Park?
Yeah, Sunghyun Park. I'm co-founder and CEO of Rebellions, which is Korean AI chip company. We're currently using Ansys tools, fantastic. We're also collaborating Ampere for National AI DC project, something like Korean Stargate. So we Rebellions, Korea's only deep tech unicorn. We recently got merged SK Sapion last December. So our focus is on inference, as mentioned, AMD and Intel talked about, especially LLM inference. So our technology, which is distinguished from other AI chip startups, is high bandwidth memory and chiplet-based technology, scalable network on chip, sub-memory systems, customized UCIe protocol, something like that.
Well, let's go then, guys. I could say that 2024 was an interesting decade in tech, just in terms of the pace of innovation. 2025 is promising to be a major year for advancement of enterprise adoption of generative AI in all sorts. We're just going to start with exploring where that technology trend is going. And Park, would you like to kick us off?
Sure. As Alice mentions, let me talk about the fundamental AI workload. We have tools, training and inference. From our perspective, a little bit complicated, but from business perspective, training is kind of research and development. This is R&D. On the other hand, inference is where the actual business begins. That's the key differentiator from enterprise perspective. So as AI services get more popular and increasingly monetized, like number 2 DeepSeek, another DeepSeek again and again, then inference traffic would dramatically goes from the edge to the cloud. Eventually, it's kind of the hybrid from the rack to the cloud. I think it's really, again, it's the year of inference. It's the year of AI service, not AI R&D anymore. Inference, that's exactly 2025.
Now, Jeff, I've been following Ampere for a long time, and you guys have had great inroads into the data center. But you're here at MWC talking about platforms for comms. Tell me about that and how you see that shaping your broader strategy.
Yeah. So like I said, we initially set out to build processors for cloud and for data centers. And what we were trying to tackle was the emerging power problem. Obviously, our processors deliver a lot of performance, but even more importantly, the focus is on delivering that performance at very, very low power. And we've all seen the complications that have occurred over the last couple of years as AI has taken hold within data centers. And as we move from training to inference, that problem just scales out everywhere. And so we've seen that scale out across data centers as they seek to keep up with the demand for running these AI models at scale in lots of locations. Well, those AI models aren't only running in clouds or in enterprise data centers. Those AI models are increasingly running everywhere. They're running out at the edge, they're running in endpoint devices, and so that was sort of the natural point for us to expand out into the comm space, out into the telco space, because those same challenges that we were seeking to solve within big hyperscale cloud data centers are increasingly now problems in telcos. And those same power problems remain. We've heard this a couple times here in the session, that the environment that this hardware is being deployed in is really constrained. It's constrained from a power perspective, it's constrained from a space perspective, it's constrained from a thermal perspective. And so those same things that we did within our hardware to solve for those problems within data centers now equally applies out into the telco space, where you have a demand for a lot of performance, and you need to deliver that in a really, really efficient manner.
Now, Jayraj, Ansys makes ridiculously powerful tools for design simulation for anything from a chip to solutions from across industries. You have a really unique perspective in terms of the environments, probably the most unique perspective on stage in terms of the environments that these foundational platforms are needing to be deployed in. What does that tell you about the broad proliferation of technology that we're talking about today?
Lots of change in the last few years. If you look at simulation engineering, actually brings kind of superpower to the Ampere and all the silicon developers. It actually brings certainty superpower, which is in the design life cycle of any silicon, you have to go through understanding whether a design has got signal integrity issues, a design has got power integrity issues. What has happened over the last few years is the billions of transistors, the scale factor, density, and now the chiplet architectures, right? You had Salil talk earlier about MI325, the multi-layered chips. You had Intel talk about the SoC, Xeon SoC. All of these are complex architectures. So today, if somebody is trying to build a very bespoke silicon, they bring chiplets, they put it all together, they have interconnects. That all also affects something called IR drops, voltage drops, so that releases more thermal and heat. So now you have to model not just signal integrity and power integrity, you have to model thermal integrity. And the chips get so hot, you have a mechanical stress warpage. And when you have that, you add new interposers. So complexity has gone through the roof. So to do simulation of all of those multi-physics at the multi-scale level, from nanometer to a chip which is at a millimeter level, to a board that is at a centimeter level, to package which is at a centimeter level, to a systems level, is highly complex. So multi-physics simulation engineering is at the core of making a silicon successful. And not just the silicon. I think, frankly, silicon to systems was a conversation we had. I think if you take the silicon, put it in a board, put it in a server, put it in a rack, and put it in a data center, you have to start worrying about data center cooling and power performance efficiencies at the data center level all the way to the chip level. So it's a very complex world.
Now, you guys have just given me, as a chip head, incredible faith in engineering innovation. And I think that we've seen that play out in the silicon arena for the last couple of years. Just incredible advancements in pushing up against the laws of physics. Where do you see this new infrastructure capability fueling adoption of AI? Park, you talked about inference is everything, right? Where do you see those leading use cases emerging as you talk to customers?
Basically, first of all, I'm not that much expert on that question, but as an individual, not the official of the CEO of the Rebellions, I'm looking for coding. Let me introduce by myself, by the way. I'm engineers. I got a PhD from MIT, and 6 more years as engineers. I was Intel, SpaceX, and Norgan Stanley. I realized that most of my professional career is, how can I say, fucked up. Because when I use my chatbot, wow, it's better than me, literally. Again, I got a PhD from MIT, but I put some of my code using not GPT-3, GPT-2. Come on, it's better than me. So coding engineer, first, that's the low-hanging, the application of the LLM, other stuff. That's the real history. Again, it's not a ChatGPT moment. Before the ChatGPT moment, ChatGPT is GPT-3. When I realized and surprised, shocked, GPT-2 using the Microsoft, that stuff, wow, that's my personal stuff, yeah.
Well, Jeff and Jayraj, I think Park just made the panel very real. Would you guys like to add anything to that?
Well, I think that obviously, the big growth here is going to be on the inference side, running the models. And I think that where we'll see a big turning point here is when AI just becomes ubiquitous and it becomes embedded in all of the applications that we're running today. So today, a lot of times we're still actively, knowingly using AI, like using ChatGPT. So you're seeking out different AI applications. I think that through the course of this year, I think we'll see AI just getting embedded into every enterprise application, and you won't even realize that you're using AI at all times. It will just become understood that AI is running in the background, and that's creating productivity, and it's embedded in every single tool that we use today. And I think some of that also may lead to growth in things like agentic AI, where it starts to become machine to machine and bot to AI bot that are actually doing a lot of this stuff behind the scenes with less active interaction by humans. So I think that'll probably be one of the things we see this year, and that's going to fuel an amazing amount of demand for AI hardware and software in every location.
I'll just add to that embedded part of embedded AI in everything. So in simulation engineering, actually we have reduced order models where we take some X number of simulations that are run instead of the detailed model. We can take the results of the simulation, train a model, and then use subsequent runs to be much more faster. There's a big initiative in every semiconductor industry operator is the velocity with which new innovations are coming out. So the time to market is shrunk, right? So there's a lot of shift left in terms of the duration that the design engineering team can apply on a certain product or a derivative. So AI is actually facilitating the speed of preliminary designs before you go into the broader finite element analysis and kind of comprehensive models, more fine-grained.
I don't know if I'm more excited about having a team of agents working for me, or apparently, according to Salil, some robots living in my house. But all of this is incredible. And just in terms of the use cases that we're targeting, just such an exciting and vibrant time to be in technology. It's going to take the entire industry to deliver this. And I know that you all represent complementary companies. Why is collaboration so important at a time like this?
Well, I think it's incredibly important. No one person is going to solve all of these problems. And I think we heard it earlier, too. The industry isn't looking for vertical solutions where one provider does everything. And frankly, that's not how innovation is created in this industry. The last couple of decades have been about creating big horizontal platforms for innovation that involve collaborations from a lot of people, that involve open source. And at Ampere, we've been actively driving this as well. It's where we've created the AI Platform Alliance last year. We have folks like Rebellions and others that are involved in that, where we're trying to build AI platforms that the industry can adopt for a variety of use cases that involve hardware from a number of different people, that involve software vendors, ISVs. And then that's also where one of the big things that at Ampere we've been able to talk about over the last week or so is the collaborations that we've had with partners across the telco space. So folks like Canonical and SUSE, Synexg, Fujitsu, Supermicro, all of the people from a hardware and software perspective that are needed in order to create these solutions. So I think the net of it is these systems are incredibly complex. Innovation happens better when it's happening across the industry, not within single companies, and we're strongly in favor of driving that.
Let me first talk about silicon industry. As mentioned, currently the designing of silicon and validating silicon gets much, much more complicated through the chip lab. It's not a single die anymore, multiple chip labs and super complicated PSI. Power and signal is totally different animals. You know much better than that. Without Ansys and without the collaboration, we can do anything, by the way. Without the open source, without the multi-source like ARM-based the CPU, always we locked in a single technology. So we need to find another options, our partners, collaboration. From the silicon layer, it gets more and more complicated. From the vertical layer, AI, just the silicon, PCI modules, server racks, data center. At the end of it, we have the hosting software. At the end of API and the service, the vertically here. Every company not to be the big tech. The Meta, I don't know, is may big all the vertical, but most of our enterprise need to be collaborating together because AI systems, silicon, everything gets much, much more complicated.
I'll just add to that saying it's an ecosystem play. That's the one line to say, because I think it's not just about us collaborating in the ecosystem. It's also the partnerships that we build with the startup ecosystem. There is 4Y. There's a 4-year from now kind of group of startups over there in MWC. Incredible amount of innovation happening in the startup ecosystem. Somehow established enterprises, you're a startup, so it helps pulling everybody together. But there's one part that we should not overlook, which is the academic partnerships. So Ansys has a special program just with thousands of institutions and universities to educate the workforce of tomorrow. I think it's so complex. As the complexity goes up, the ability to have curriculum, content that the kids can learn, engineers coming out of school. I also went to MIT, but I still struggle with the stuff that we are dealing with today, right? But what I'm trying to say is, it is important, the curriculum, the content, the opportunity, and the software is available to universities so they can adopt and learn and evolve the next generation of products. So academic partnerships are also very, very important.
I think one of the things that makes this moment so unique in terms of the trajectory of technology innovation is how it's playing out on the geopolitical front. And most recently, the EU's announcement of $200 billion of investment in AI infrastructure and delivery of AI capabilities across the continent. How do you see that playing out, and what is the role of industry in the geopolitical landscape of technology evolution?
Oh, geopolitical issue. I don't know why. It's kind of between, first of all, the United States and China. At the end of the day, it's kind of the other world, and EU and the Kingdom of Saudi Arabia in the Middle East. Basically, no idea at this moment. This is opportunity or risk. Nobody knows yet. But point is, even with this geopolitical risk, we need to expand our collaboration. We need to secure a second source. We need to secure other products. That's the, again, talk about ecosystem. Today, we all hardware, so we need our x86 ARM at the end of the RISC-V or something. Also, software side, the PyTorch, TensorFlow, and other frameworks. Also, we need to be very specifically looking at other algorithms like DeepSeek or something. So basically, I have no idea. I'm not that much expert on that. But we need to be preparing another supply chain management using the not leveraging or preparing the geopolitical issue out there, HBM, all the chipless stuff. Yeah.
Well, I think the geopolitical environment right now, I mean, I think that it's actually a wonderful opportunity. I mean, I think the fact that this is at the forefront of these national conversations and conversations within the EU and in the US and elsewhere, I think it's a great opportunity. I mean, 10 years ago, nobody cared about what was happening within the semiconductor industry. There was no discussion about it whatsoever. There was no interest. And I think that it's a great opportunity, the fact that politicians and business leaders do really care about this, and they're putting a lot of money into this. So, whether it's the money that the EU is putting aside for this, or, some of the projects that are happening in the US, things like Stargate, some of the private-public partnerships, there's a lot of money in here to be invested. So it's a great opportunity for, technologists to help to direct that into great places. And I think it's not just about also building out super high performance systems. There's also the sustainability angle to it as well. And we've seen, in France, there's been some initiatives by the power generation and power distribution entities to really start to plan ahead and think about where the power is going to be coming from to fuel all these AI-driven data centers and all this infrastructure in the future. So I think there's also a great opportunity not just to put money to work on the pure technology and performance side, but we can really start to create some lasting sustainability change in using this current AI phase to do it. I think just amazing opportunity to lay a groundwork for things that will go way beyond the semiconductor industry and way beyond the comms or the data center space.
I agree. I changed my mind. It's a great opportunity. Thank you. I'm persuaded. Yeah.
I think I agree with both of them. It's a great opportunity. The reason is it's not just the US CHIPS Act or the European investments. Japan, I was there, they have significant amount of money going in. India, just VLSID 2025 was there. There's like $35 billion invested by the central government to put some foundries in. But this notion of strategic autonomy in a supply chain is kind of not real, because we all work together, we all have a role to play in this. So, but getting new foundries, getting new semiconductor designs in, fueling systems, solutions across the board, country-specific or region-specific or global for the entire human advancement is a great thing. So it's a big opportunity for all of us to get involved in.
I think we've got time for one more question for the three of you to prognosticate and discuss. I'm just going to paint a picture. It's 2027, and we are back on this stage talking about how AI adoption across enterprises and across verticals and across use cases has evolved. What are we going to be talking about as great examples of technology that has been embraced by industry? And where are we going to still be stuck in terms of core capabilities in a couple of years' time? Who'd like to go first?
It's me? Okay. It's not 4 years from now on, 3 years from now. Basically, really hard to answer, but from my perspective, we're still struggling power landscape. Even if we have a low power CPU, low power MPU, and very efficient CAD tools, still we are power hungry. Even with a very low power device, the systems and the algorithm get larger and larger, like AGI at the end of the day, maybe not 3 years, a couple of years later, we really have huge models operating robotics, I believe, the physical AI. Still, we need back to the basic plants. So we can use the on-device here edge, or it doesn't need to be data center cloud. Just as Intel AM talk about the just at data center space, the rack using the on-device through the cloud, but still we are power hungry. So right now we talk about the data center efficiency, much more efficient compute platform to enhance all the AI business is real. That's a challenge and opportunity I saw right this moment. But nobody knows what's going on 3 years later. So yeah, I'd like to hear your opinion.
Well, I agree. I do think that power and sustainability is going to still be one of the things that we're struggling with. And we're going to have to solve this on all fronts. We need more green power, more power generation. We need more power distribution to get that power out across the grids and do so in a resilient way. We need more efficient data center technologies and platform technologies. And we're going to need really efficient processors and accelerators that are serving up all these workloads. But I don't think this is one where the job's not going to be done. The demand for AI seems to be unabated, and so I think that in a couple of years we'll have made amazing progress on all those fronts. But our job's not going to be done. It's going to take hard work across all those different aspects for a long time to continue to keep up with demand. But I think on the more positive front, I think we'll get to a point in the next couple of years where maybe we're talking about AI in a different way on the stage. Now AI is still kind of a separate topic. It's what are you doing with AI? And I think we'll get to a place where AI just is a part of compute. It is AI compute. AI is sitting in every device. AI is a part of every single workload. And so it's not necessarily a separate conversation to be had. It's a part of every conversation that we have in a couple of years here at MWC.
Yeah, I think I agree with everything that was said. Additionally, because this is Mobile World Congress, I kind of think based on the use cases that we all live every day with all our comms devices, hopefully in 2 years, 2027, we'll have some integration between terrestrial, aerial, and space communication technologies so that it's seamless, ubiquitous, and we get access to communications everywhere in the world. The other part is simply the sensing part. I think in a few years' time, I'm hoping that it's not just joint communication, and sensing. So all of these network compute fabric extends from the cloud all the way to the edge. And we have humanoids, robots, all that Salil talked about. And we can have a good environment, a self-autonomous feeding environment. And that's not actually a long-term plan. In 2 years, it's viable based on some of the inferencing capabilities that are at the edge. So super exciting times ahead for us.
Well, guys, this has been a fantastic panel. Thank you so much for your insightful and creative answers. And have a great rest of your week at MWC. And thank you to the audience for participating today. It's been a real pleasure to host.
Thank you, Allyson.
Thank you.
Thank you.